Hello and welcome again to Apex Math. Today we're going to do a lesson on scientific notation. What scientific notation is a particular way to write numbers using powers of 10 and moving your decimal points. So scientific notation always starts off with a number, a decimal point, and then you can have any number of numbers after the decimal point. But you have to have only one number here and then the decimal point. So it can be something like 3.2 or 5.763 or 7.1492. They always start off with just one number here and a certain number of numbers to the right of that decimal point. And then they're always times 10 to some power. So, and that number can be a positive power or a negative power, times 10 to the third, times 10 to the negative 2, times 10 to the eighth. So that is the form of scientific notation. So the very first thing you want to do when learning about scientific notation is to make sure that you know how to get a number into this form. So that's the first thing we'll work on. All right, so let's take some numbers here. Let's take 325 and 0.062 and 0.00394 and 521.67. And we are going to talk about putting these numbers in scientific notation. So the first step in doing that is figuring out where that decimal place needs to go. And remember that the decimal place needs to go, let's rewrite the numbers here, 325.062, 0.00394, and 521.67. So there are the numbers just written again. But now I'm going to use the yellow again to highlight where the decimal point needs to be to make that form that's needed for scientific notation. Now notice that here there is no decimal point, but we know that a decimal point, if it's not written, is actually right there. So even though it's not written on that particular number, a decimal point always falls at the whole number at the end of that whole number. So for each of these numbers, in order to fit that form, I have to have one number here and then the decimal point. So I'm going to look here. The first actual whole number that's not a 0 is 6. So that number, that first number there, that's where the decimal point is going to need to go. If I look here, 3 is the first. Actually, it's a natural number. It's not a whole number because we don't want the zeros. And then here, if I look, this is where I need my decimal place to go. So the first counting number that you have, and then a decimal point, and then the numbers afterwards. So that's the first step, is figuring out where my decimal place needs to go. The next step is how far did I move that decimal place from where it originally was? So if I look at this and I go, all right, it was here before at the end of the 5, and I needed it to move to the 3. I take and I bunny hop to see how many places it moved. It moved 1, 2. So this moved 2 places. How many places did this move? Well, it needed to get from this point here to in front of the 6. So it moved also 2 places in a different direction, but it still moved 2 places. This one was here, and it needed to get all the way in front of that 3, so it bunny hopped 3 places. And then this one also bunny hopped 2 places, 1, 2, in order to get to that location of the 5. So each of these has moved this many places to get where we needed to. So I'm going to go ahead and erase this middle column that we used to help us out, give us some more space. And now we've talked about how far this needs to move, and we said that our numbers are now, this one is 3.25, and it's going to be times 10 to a power, and we're going to fill that power in. And this one's going to be 6.2 times 10 to a power, and we're going to fill that in. And this one's going to be the 3.94 times 10 to a power. And this one's going to be 5.2167 times 10 to a power. And we're going to fill that in a second. These are the numbers that over here that are going to go into the box. We just need to figure out whether these numbers are going to be positive or negative. Now this is the only tricky part of the problem. And this is where I use a special trick, which is I write this step out with the boxes of what I need. And I always look from this step, and this is where it's important, back to the original number. And let's try to clear out here what our original numbers were here. This is 325. So I'm going to rewrite this as 325. 325. This was 0.062. So now I got my bunny hops. I can't see it as well here. So I'm going to write these a little bit clearer. 0.062. This one is 0.00394. 0.00394. And this one was 521.67. 521.67. 521.67. All right, so working in this direction, from the number that, the scientific notation number, back to the original, does it get smaller or larger? So from this number to this number, it gets larger. 3.25, going back to where we started from, gets larger. 6.2 to the original, it gets smaller. 3.94 back to the original, gets smaller. 5.2167 back to the original, gets larger. If it gets larger, the number is going to be a positive. If it gets smaller, the number is going to be a negative. Oops, that's a 2. And then this gets larger, so this is a 2. And that is how we do the scientific notation. The key thing is that you have to look in the right direction, because if you look from here to here, you'll end up putting the wrong sign. So you always have to look from once it's in scientific notation back to the original and decide, does it get larger or smaller, to decide your sign on your number. So we'll do just a couple more and we will be done. So let's just do one more here. Let's say we have 0.0341, and we want to write that in scientific notation. So remember that our first step is to rewrite it with the number moving the decimal point. So I know that that has to look like 3.41 times 10 to a power, because it's going to have one number, a decimal point, and then the rest. Then I look back from here to here, and I see that this, going from my scientific notation to what I originally had, gets smaller. And then how many decimal places did it get moved? Well, I had to move it 2 places in order to get this 3.14. So it's going to be 2, so it's going to be a -2. And remember, important thing here, of course, is the direction in which you consider it. From the scientific notation direction back to the original. Does it get smaller or larger? And that's it for our lesson today. Next time we will look at how to convert from, if we start off with scientific notation, to the standard form. Thank you very much. Hope you enjoyed this episode of Apex Math.